Nonlinear systems include at least one nonlinear equation. And nonlinear could mean lots of things, right? It could mean quadratic, cubic, quartic, quintic, could mean square roots, cubed roots, any kind of rational exponent. It could mean logarithms, it could mean exponentials, rational functions. But for the most part, I believe what they're aiming for from the SOLs is quadratic, really just quadratic. You could have one linear equation and one quadratic, or you could have two quadratics. But the thing is that up till now, you think, you've been taught that the shape of the graph of a quadratic is a parabola. That is not necessarily true. That's true when you have a quadratic in one variable, but a squared term in one variable. But when both variables are squared, you get a bunch of different shapes, including, right, parabola is the first one, but circles, ellipses, and hyperbola. Those are all quadratics. So the systems, as you look at them, can look like that's the intersection. It does look like it's intersecting of a parabola and a straight line, right? There's a parabola and a straight line. There's an ellipse and a straight line. Looks like two intersection points. Okay, you see the circle. That is obviously a circle. These two branches of the same shape are called a hyperbola. That's one shape. In fact, you know that shape. That is the graph of an inverse variation. Right? We did inverse variation before. We had one branch in the first quadrant. We had one branch in the third quadrant. If you would have taken that graph and rotated it 45 degrees, then you would have had this hyperbola here. Notice how many intersection points we've got. 1, 2, 3, 4. So nonlinear systems, that's what we're looking at.